Hey, look, another function for us to tangle with. They want concavity intervals and any points of inflection, and these things are all based on the second derivative, so we don't need anything about increase or decrease. We can blow right through the first derivative. We're only getting the first derivative because we needed to get the second. So 4 times 1/4 cancels out. X to the third minus 3x squared minus 2 is our first derivative. F double is going to be 3x squared minus 6x, full stop. Okay, so that's our second derivative, and if we can find any places where it's 0 or where it's undefined, that's our list of interesting values that we're going to look at. I kind of avoid calling these critical numbers just because that term is kind of closely associated with the first derivative, but if you call these critical values of the second derivative, I suppose that's fair enough. So we want this to equal 0. This thing is very factorable. We can take a 3x out of both terms, and that leaves us with x minus 2. And that tells us that we have a root when x is 0, and we have a root when x is 2. Those are the two places where the second derivative does interesting stuff. So here's a number line with 0 and 2 on it. Let's see how this thing behaves. Sine table, 3x. You might remember doing these in the pre-calculus section and wondering what the point was. We kept saying, trust us, you're going to use these a lot later. Well, here we are. Can't do increase or decrease or concavity without using a sine table, unless it's a trivial problem. Okay, so here's our second derivative. I've got the individual pieces, and then I've got the grand total. 3x, if we're lower than 0, is negative. If x is 0, then 3x is 0, and after that it goes positive and stays that way. If we have a negative number and we do x minus 2, we get a negative. 0 minus 2 is negative. 1 minus 2 or whatever is negative. 2 minus 2 is 0, and bigger than 2 minus 2 is positive. So for our second derivative, we get negative times negative, 0 times whatever, plus times negative, plus times 0, plus times plus. So this means our function is concave up. Here it's concave down. Here it's concave up. And both of these places where the second derivative is 0, we would say are inflections. So for intervals of concavity, we'd have concave up below 0 and above 2. It's concave down between 0 and 2. We have an inflection at 0, and we have another inflection at 2. Now, again, when they ask for a point of inflection, we should probably give them 2 coordinates. So we need to take these x values and put them not here, not here either, back in the original function to see what our y coordinates are. So plugging in 0 is one of the easier things there is in the world. 0 minus 0 minus 0 plus 5 comes out to 5. That was fun. 2, less easy. Let's see, 2 to the 4th is 16, quarter of that is 4, minus 8 is negative 4, minus another 4 is negative 8, plus 5 is negative 3, if I did all that correctly. It's probably a little more than I should be doing in my head, but if I messed it up, I'm sure you'll let us know.